Math 3, Unit 3, Section B. So yesterday we just talked about the degrees and kind of what the end behavior was of all these graphs. Today we're going to actually talk more about how they're actually graphed and what they look like. Okay, so the first thing we're going to talk about is to find the degree of a factored polynomial. So yesterday they were not factored, right? We could just find our highest exponent, that was our degree. Today we're going to be looking at a factored form. Okay, so in order to find the factored form, you have to add up the degrees of each of the factors of f of x. Now, when you're adding up the factors, it has to do with like your x's. Just like when we're dealing with our coefficients, right? It's with an x, okay? So do you see how this factored has an x? Okay, so this would be, if we're finding our degree, so I'm gonna write right here, degree. Okay, we would add 1 here, and then this one, again, we have another x, so that would be 1, and here is another x, so that would be 1. So this degree would be 3. So I'm just going to kind of put my answers over here. So the degree is 3. So they want us to find the degree, the leading coefficient, and also we want to find the end behavior. So it didn't state that there, but we're going to find the end behavior. So the leading coefficient, it says to find the leading coefficient of a factored polynomial, we will just multiply together the leading coefficients of the factors. Okay, so I'm just going to put LC for leading coefficient. And so this 2 is part of the leading coefficient, okay? And so we're going to multiply 2 times, and then you're going to take the number with your x's in front of each of your factored forms. So if a number is not there, that number is actually a 1. So we're going to go 2 times 1, and then this one we're also going to multiply by a 1, and then here we're also going to multiply by a 1. And when we multiply all that together, we get a 2, okay? So my leading coefficient is 2. What is important about the leading coefficient? You need to know if it's what? Positive or negative. And then the degree is important. So when this degree is odd, that means I'm going to go in the opposite directions because odds are opposite. So my end behavior, and I'm going to put EB for end behavior. Okay, on the right side, which direction will I end up going for this? My right will be positive infinity, and my left will be
negative.
Very good, negative infinity. Okay, so that's all we got there. So my degree was 3, and because it's 3, I know it's odd, so they're going to go in opposite directions. And then I know that my right is 2 because that's positive, so that means the left has to be negative. Okay, do we have any questions on this? Okay, so B. We're going to do this one together, and then I'm going to have you try one on your own. So we need to start with our degree. Okay, and how do I find my degree? We're going to look at our exponents and actually see how this one has an x. This exponent, though, of this one, there are how many? 2. So we're going to do that as a 2. On this one, it has an x, and we're going to add that, and this time that one has how many? 3. And then this one, we have our x1, and this one has an exponent of a 1. So up here, these are the 1 exponents that we added, the 1, 2, 3. So 2 plus 3 plus 1 equals 6. Okay, so my degree is 6. We also want to find our leading coefficient and my end behavior. I'm just going to write this all out. Okay. So the leading coefficient, we're looking at the numbers now.
Negative.
Good. So we start with negative 1 times 1 times 1 times 1, right? Wait. Negative 1, 1, 1, and 1. Okay. So that multiplies and is negative 1. So my leading coefficient is negative 1. Based on the leading coefficient being a negative, we know the right side is going to go to negative infinity. And then the left side will go Also to negative infinity. And how did you know that? Because the degree is even. Okay? So those are my answers. Okay, are you guys ready to try number or part C on your own? Okay, so when you get the answers, raise your hand and I'll check them. Oh, really? Yeah. Like most of you got it correct. Good. So my degree, when we were finding the degree, we are looking at our factors and their exponents. Okay, so what did you guys get for this one? 1 plus 2 plus 1 equals 4. Okay, so my degree is 4. My leading coefficient, let's make sure you guys did this one right. So we have here, we start with what? Negative 2 times 1 times 1 times negative 1, because we're going with the number with the x. Okay, so that's a negative 1. So when you multiply all that out, you get a 2. Okay, so the leading coefficient is 2. Okay, and my end behavior for the right side then will end up going to the positive infinity, and the left will also be positive infinity. Okay, do we have questions there? Are we okay with why that one is the way it is? Yeah? So whenever you're taking your coefficients, remember it's the number in front of your x, or if you took a number, a GCF out of the beginning, you have that number as well. Okay? All right, on D. Let's do this one together. So starting with our degree, we have 1, 3. Now this one is kind of tricky. Normally when you have factored forms, normally it's just a plain x, but sometimes you have an x squared. So on this one, this x squared, it's actually going to be a 2 to the first power. Which, do you guys remember what you do with powers to powers? You multiply. So 2 times 1 is 2. So let me just kind of do like a side example here. If this had been 4x squared plus 1 to like the second power, you would end up going 2 times 2, and that would be 4. Okay? So if you have, the x has an exponent inside your factor, you have to take that exponent, okay? And if there's an exponent outside, you multiply it together. Well, of course, all of them have an exponent outside, but if I multiply 2 times 1, it's still just going to be 2, okay? So powers to powers, you multiply. And for instance, like if you have x to the third to the fourth power, you know that means that you have 4 x to the thirds, which is x to the 12th. So that's what we mean by powers to powers. You multiply them, so that would be x to the 12th, okay? So on this one, when we're doing our degree, we have 1 plus 3 plus 2. And when you add all those up together, we end up getting 6. Okay, so my degree is 6. My leading coefficient, let's go and figure that one out now. And so our leading coefficient, what numbers will I multiply together?
3.
Okay, 3. 1. Not 1, but negative 1.
What about that first one?
Oh, you're right. Sorry. That is a positive 1. And then the next one is a negative 1. Thank you. And then the last one is a 4. And so we multiply all that together and we get negative 12. Okay, so my leading coefficient is negative 12. Based on it being an even degree and the leading coefficient is negative 12, on the right side I'm going to go to negative infinity, and on the left side I'm going to go to negative infinity, because evens go in the same direction. Okay, any questions so far? No, this is pretty easy, yes? We're good? Okay, so the next thing is finding the y-intercept. We have already done stuff with finding the y-intercept, but I want to make sure this makes sense to you. So a y-intercept means that it's going to cross the y-axis, right? And so if I have these points on the y-axis, what do all of them, how would I write this ordered pair right here? It'd be like 0, 1, right? This one would be 0, 2. Down here we have 0, negative 1. So any y-intercept, the x value is 0, and you're finding the y value. So when you're doing this in equations, you are plugging in 0 for x and solving for y when you're finding your y-intercept. Okay, so you're putting 0 in for x, and then you find the y value. So you might want to make a note just so it makes more sense to you, but you're plugging in 0 for x and finding y. So that's how you get an ordered pair of 0, comma, and some number. Okay? And that's what they've said in those directions, but maybe that makes a little bit more sense to you. And so the same goes for an x-intercept. If I have all these points on the x-axis, for instance, if we're looking at just like a couple of these, okay, on your x-axis, like this point right here is actually 1, 0. This point is 2, 0. So on your x-axis, what are you doing? Exactly, you're plugging in 0 for y and solving for x. And that's how you end up getting a number, comma, 0. Okay, so on this next problem, or these next couple examples, we are just going to find the x and y intercepts, okay? And then we're going to end up putting all of this together. So if we start with finding the y-intercept, okay, what am I going to end up doing? Yes, we're going to plug in 0 for x. Okay, f of x is also known as y, right? So we could write this as y equals 2, parenthesis, 0 minus 3, times 0 plus 1, times 0 plus 5. So I just plugged in 0 for all of the x's. And then we'll simplify. So I have y equals, it's going to be 2 times negative 3 times positive 1 times positive 5. Okay, and you could get a calculator out if you wanted to and multiply all those together, or hopefully you can do that in your head. But when you multiply those, what does y end up equaling? Negative 30. So my y-intercept as an ordered pair is what? 0, negative 30, because we plugged in 0 for x and we got the value of negative 30 for y. So that is my y-intercept. Okay, on each of these graphs, because they're all functions, it will only cross the y-axis one time. And so we will only have one y-intercept, because if you had 2, it wouldn't be a function because it wouldn't pass that vertical line test, okay, because it'd be hitting 2 points at the same time. So there will only be one y-intercept, but there could be multiple x-intercepts. Okay, so how do we find the x-intercepts? Good. So for the x-intercepts, we plug in 0 for y and we solve for x. So we have 0 equals, and then you have 2 parentheses, x minus 3 times x plus 1 times x plus 5. Now the nice thing about these problems is that it's already in factored form. And so normally when this is set equal to 0, once you're factored, you set each of those factors equal to 0. Okay? So if I'm doing that, I'm just going to kind of draw lines between each of these. I would go 2 equals 0. Now, does 2 equal 0? No. So I just cross that one out. That is not a solution. Okay? X minus 3 equals 0. And when I solve that, I'll end up getting x equals what? 3. Okay? This one, x plus 1 equals 0 would give me x equals negative 1. And this next one, x plus 5 equals 0 would give me x equals negative 5. And then we want to write each of those as ordered pairs. So x-intercepts would end up being 3, 0, negative 1, 0, and negative 5, 0. So that means this graph, the line is going to go through it, or the function is going to go through each of these points on the x-axis. All right. So we're going to do F as well. So in order to find my y-intercepts, what will I do? Plug 0 in for x. So we have y equals negative 2 times 0 minus 3 times 0 plus 1 squared times 1 minus 0. We get y equals negative 2 times 0 minus 3 is negative 3. I like to kind of take care of the squares in one step. So 0 plus 1 is 1, and 1 squared is 1. And then 1 minus 0 is 1. And we multiply all those together, and we get 6. So my y-intercept, as an ordered pair, we would write that as 0, 6. Any questions? Okay, so now we're going to go to our x-intercepts. Now, some of you like to skip steps. I'm okay with you skipping some steps, okay? But I think that you originally, though, need to always plug in the 0 where it's supposed to go, like how we're plugging in zeros here. Okay, you need to show that we're going to plug in 0 for y. So I want you to at least write out 0 equals negative 2, parentheses, x minus 3, x plus 1 squared, and then 1 minus x. Okay, and then at this point, I'm okay with you, instead of writing things out, this one we know doesn't work, right? This next one, I'm going to get x equals what? Not negative 3, positive 3, because we move it over, right? It becomes positive 3. This one will be x equals, it's going to be negative 1. So we have two x plus 1s, but if you put each of them, like x plus 1 equals 0 and the other x plus 1 equals 0, both of them are going to give you the answer of negative 1. Do I need to write a negative 1 twice? No. Okay, but this actually does have some meaning to it, and we'll talk about that a little bit later. What answer will you get for this one? It's going to actually be positive 1. So let me just show you on this one. If I go 1 minus x equals 0, I would want to move the x to make it positive, and so I'd add x to both sides, and I end up getting 1 equals x. Okay, so if you're ever not exactly sure what it's going to equal, then just write it out and set it equal to 0 and solve the equation. Okay, and so my x-intercepts then, if we write these out, are what? 3, 0, negative 1, 0, and 1, 0. Okay? Any questions on here before we move on? Okay. Does everybody have all that? Okay. Questions? No? All right, moving on. Okay, so the next thing we're going to talk about is multiplicity, okay? And so multiplicity of an x-intercept is the number of times that particular x-intercept occurs. So we just kind of talked about on the previous page how when you have a squared, there's actually almost like 2 ones, okay? But I want us to actually go down and look at this bottom part, and then we'll go back up here to these top examples. So it says the multiplicity of an x-intercept is odd. If the multiplicity is odd, then the graph of the polynomial passes through that x-intercept, okay? If the multiplicity of an x-intercept is even, then the graph bounces. And bounces means that it like touches and goes back. Okay, and so if you look right here at this graph, do you see how this one is passing through? It's going through the x-axis. So if it's passing through, that means it is an odd degree or an odd multiplicity. If it bounces, so see how it comes up and it touches it and it goes right back down, it doesn't actually go through the x-axis, but it touches the x-axis, that one has an even multiplicity. So this one right here, this bounce, means it would have an even multiplicity. And this one passes through and it would have an odd multiplicity. Okay. So your multiplicity, knowing these values, is coming from your x-intercepts. Okay, we know that the y-intercept, it will always just pass through at one time. Okay. So if we go up here to these, we need to state the x-intercept and whether they're multiples of the following polynomials, or what their multiplicity is, sorry. So in order to find the x-intercepts, what do we do? Okay, we're going to plug in 0 for y and solve for x. So we have 0 equals negative x minus 2 squared times x plus 1 to the 3rd power times x plus 7. When we set these equal to 0, okay, we end up for this one, we will get x equals what? 2. For this one, we're going to get x equals -1. And this one will be x equals -7. Okay, so we're going to come over here and write our ordered pairs and then talk about what's going to happen with each of those points. So, yes?
Why would the second one be negative?
Because there's actually going to be like 3 negative ones. So when you have something to a 3rd power, you would be setting each of those x plus 1's equal to 0. And they would all give you an answer of -1. Okay? So you're always just setting that 1 time equal to 0. You don't have to do it 3 times. But then the 3rd power is basically odd, so that's telling me it's going to end up passing through that point. Okay? And so that's what we're going to talk about now. So we have one ordered pair is 2, 0. Okay? So what multiplicity does this have? It has a multiplicity of 2, okay? And 2 is even, and even means that they bounce. So I'm going to put bounce. Okay, so then my next ordered pair, my next x-intercept, is -1, 0. Now that one has a multiplicity of what? Of 3. So your multiplicity is coming from that exponent. It has a multiplicity of 3. And since it's odd, that means it's going to pass through. Okay, and then my last x-intercept is at -7, 0. That one has a multiplicity of what? 1. And since that is odd, it's going to pass through. Now I'm going to end up abbreviating things. So like for bouncing, I'm going to put a B, and for passing through, I'm just going to put a P. Or you can put a PT if you want to. Does that sound okay? All right, so let's do this next one. And then our last part is going to be actually graphing, where we're putting everything together. Okay? So we're going to do what first? We have to get our x-intercepts. So we're plugging in 0 for y and solving for x. So I have -2, parenthesis, x minus 3, parenthesis, x plus 1 squared, parenthesis, 1 minus x. Okay, we set each of these factors equal to 0 and find what x equals. Okay, so on this one, x will equal 3, x equals -1, and x equals +1. Very good. And again, if you're ever not sure with any of those, actually write it out and solve. Okay? All right. Do you guys want to try to write out these ordered pairs and the multiplicity and whether they bounce or pass through on your own? Okay. So try it on your own. If you have a question, raise your hand. Otherwise, I'll come around and check them. So you should have got, the first one was odd, so it passes through. The second multiplicity was even, so it bounces. And then the third one is odd, so it passes through. Do we agree? So I'm just going to write these out here kind of quick. So I have 3, 0, multiplicity of 1, which means it passes through. Okay, next one is -1, 0. This one has a multiplicity of 2, and that means that it's going to bounce. And then the third one is 1, 0. It has a multiplicity of 1, which means it passes through. Okay? And then we understand the difference down here again of what it means to bounce or pass through. Correct? Okay. So now for everything together, we have 2 examples. And there are some steps up here to help you with graphing. But when you're graphing, you first need to find your x-intercepts. And I normally will write down, like, is it going to bounce or pass through? Then we're going to find our y-intercepts. And then we also need to figure out where do our end behaviors, what happens at our end behaviors. Okay? So let's go ahead and start with finding our x-intercepts. Okay? So our x-intercepts, we plug in 0 for y and solve for x. Okay? So everyone needs to be writing at least one example down here. Here we go. Okay, I'm going to move this up here. All right. Okay, so we're looking at number 1. We set each of those equal to 0. So when I end up solving this, we get x equals what? -2, x equals 1, and x equals -3. So I have these ordered pairs, and they will be -2, 0. And at -2, 0, that has a multiplicity of what? 1, which means it will pass through. Okay? Then I have an ordered pair that will be 1, 0, and that also has a multiplicity of 1, which means it will pass through. And then I have the ordered pair of -3, 0, which also has a multiplicity of 1, and it will pass through. If this is me, I think it's easiest, I go and plot all these points right now. So I go -2, 0, and I put a P here, so I don't have to be like looking back and forth. I know it's going to pass through. Okay? I go to 1, 0. I'm also going to put a P here to remind myself it passes through. And then we have -3, 0, and another P for passing through. Okay? The next thing we need is our y-intercept. And to find our y-intercept, what did we do? Very good. Plug in 0 for x. So I have y equals negative parenthesis 0 plus 2 parenthesis 0 minus 1 parenthesis 0 plus 3. Okay. So y equals -2 times -1 times 3. And when we and when we multiply all that out, we get y equals what? 6. So that ordered pair is 0, 6. So on our y-axis, we're going to make a point at 0, 6. You'll notice on your homework that they don't actually mark the y, because sometimes the y is like 64. So you can just draw a line and say this is 64. Okay, this one, it's 6, so it's nice. So I'm going to go on my graph and make a point at 6, 0. Okay, so coming back up here, there's my point at 6, 0. Okay, so now we need to know the end behavior. Okay, so what degree is this going to be? And we don't have to write it all out if you guys know. So we would just count. This is 1, 2, 3. Odd degree, right? So that means my end behaviors are going to go in opposite directions. My leading coefficient, though, we're going to have to multiply this out. And so we would have -1 times 1 times 1 times 1. So I end up getting a -1. Now, instead of writing like right and left, let's just on the graph itself write the right end behavior is going to end up going to the -infinity. And my left end behavior, because the degree is odd, my left behavior will go to +infinity. Okay? And so that will help me when I'm graphing. Does that make sense? So that means that over here, this side is going to end up going to +infinity, and over here, this side is going to go to -infinity. Are we okay with that? And then now this says passes through. So this means I take this line, and I'm going to do a different color just so we can see what's happening. So it passes through, but then it has to come up, and it passes through again. And then it goes through the y-axis, and then it goes down, and it passes through again. And that's it. Okay, questions on that? Okay, we're going to do this last example. So, starting with our x-intercepts. 0 equals x squared times x minus 1 squared times x plus 4. Okay, now you notice on this one that you have an x squared at the front. So when you set x squared equal to 0, what does x equal? 0, right? So if I were to go x squared equals 0, if I want to get x by itself, I'd take the square root of both sides. The square root of 0 is just 0, okay? So we have x equals 0, and then I have x equals 1, and then I have x equals -4. So let's write our ordered pairs. That means my first ordered pair is 0, 0. Now at 0, 0, the multiplicity is what? 2, which means it will bounce. Okay, the next one, my ordered pair is at 1, 0. It has a multiplicity of 2, which means it will bounce. And my last one is going to be -4, 0. It has a multiplicity of 1, so it will pass through. Odds pass through. Okay, so let's go up to our graph and go ahead and plot each of these points. So 0, 0, it's going to be bounce, so I'm going to put a B. At 1, 0, it's also a bounce, so I'm going to put a little B there to remind myself. And then at -4, 0, I'm going to put a P for passing through. Okay? Am I going too fast? Are we good? Okay, so next I need my y-intercept. So we go, our y-intercept, we plug in 0 for x's. And so I'm going to move this up so you can see what I'm doing. So we will have y equals 0 squared times 0 minus 1 squared times 0 plus 4. Well, that will make y equals 0 times -1 squared would make a +1 and 4. But 0 times anything is just 0. Okay. And so that ordered pair is 0, 0, which is already an x-intercept. So I already have that point on there. So there isn't another point right now to put for my y-intercept. That's where the line is going to cross the y-axis and also the x-axis. Okay, so now what do I have to do?
Degree.
Good, degree. So real quick, what is my degree going to be on this one? 5 is correct. 2 plus 2 plus 1. Okay, my leading coefficient will be 1 times 1, which is 1. It's positive. So since my degree is odd, they're going to go in opposite directions. So on my right side, it's going to go to positive infinity, and on my left, it's going to go to negative infinity. So on the left side right now, I can put an arrow going down, and on the right side, I can end up putting an arrow going up. And then we're going to fill in the rest. So since this one passes through, I go through it. Okay? And then we go to our next point. Now this one says bounce. So do I go through that point? No. I just turn and go back up. And then I curve around, and it says bounce again. And look, it does bounce again, doesn't it? And that's it. Are there any questions?